Hey all you cool cats and kittens. Welcome to chemistry. I have been watching too much Tiger King, y'all. It is the week of April 20th and it's our first lesson. Today we're just going to learn some rules about solubility. So 3 things we should be able to answer by the end of this lesson. Okay. Will it dissolve? And that's an easy rule. It's like dissolves like. How fast will it dissolve? And how can we make something form solution faster? There's 3 things. And then how much can dissolve. Okay. So here's the first thing for y'all to write down. Please push pause as you need. I'm not going to give as much time as you probably need to copy down notes. So push pause as you need, okay? I don't want you to feel like I'm rushing you. So here's our first rule. Will something dissolve or not? And the rule of thumb is like dissolves like. Okay, so polar solvents dissolve polar solutes. Polar things are attracted to each other. And then nonpolar things dissolve other nonpolar things. So we learned last week that polar means it has a slight charge to it. So there's a partial positive and partial negative. So that is going to be attracted to other slightly charged things or ionic things like salts, okay? Because you have ions with positives and negatives. So this is just a little visual to show you that, okay? Like dissolves like. Magnets are attracted to other magnetic things. So you're going to have the negative ends of oxygen and water will surround this positive region, this positive sodium ion, and then the opposite. You have your slightly positive hydrogen end of water will attract this negative chloride ion, okay? Now, nonpolar molecules have no magnetism. They are not attracted at all to water. In fact, they're hydrophobic, which we also learned about last week in our lesson. That means water fearing. Okay, so that means a molecule like this saturated fat right here has no slightly positive or negative end, so they will actively avoid water. Okay, they're water fearing, which is why oil and water don't mix, because water, polar, oil, nonpolar. Okay. Oh, I've got such cringy jokes today, y'all. So here we've got water saying, hey, oil, want to hang out? And oil says, I can't mix with you guys. Hydrophobe. That's so funny, I know. This one's actually fantastic. You've got this fat molecule and this water molecule. And water says, I'm sorry, we just can't be together. Is it because I'm fat? Yeah, that's, oh boy. You guys know you missed it. Okay, solvation. You don't have to know this vocabulary word, but you do need to understand the process for what comes later in the lesson. So solvation is this process where water will surround a particle to dissolve it. Okay, so it's the attraction then between that solvent to the molecules or ions of a solute. Now remember, solvent, the bigger word, is the bigger amount. So that would be water. Molecule of solute, we're talking about what's getting dissolved. So the hot chocolate powder or the sugar or the salt or whatever is in your solution. Okay, so it causes this reorganization, and it's only if there's an attraction between it. So the polar, slightly negative ends of oxygen will surround the positive ion, okay, and that will continue until you run out of solvent, until you run out of water. So once all of the water in the solution is used up surrounding and dissolving a molecule, then dissolving has to stop. So if you keep adding scoops of hot chocolate or keep pouring chocolate syrup into your chocolate milk, eventually you're going to start to see it settle at the bottom. And my children do that all the time. You end up with this like little layer of just chocolate syrup at the bottom that no matter how much you stir it will fall back down. And that's because there's nothing left to keep dissolving it. Okay? Now, how fast you're able to have water surround those solutes depends on how fast you're able to form a solution. So in this case, you see a salt crystal where it's pretty thick, or maybe you can think of it as a sugar cube. The molecules in the center can't dissolve until the surface area, the stuff on the outside, dissolves. So we'll get to that in just a couple slides, but I wanted you to have that visual. More S vocab words. I think there's a total of 14 vocabulary terms that start with S this unit. I'm trying to focus on like 6 of them for distance learning. So solubility is the ability to dissolve. How fast does it dissolve? How much can dissolve? Okay, so that's the definition here. The amount of solutes that can dissolve in the solvent. So small word, solutes like sugar, that can dissolve in the big word, like milk or water. Okay, so if I say you want to increase the solubility, you want it to be more dissolvable. You want to have that sugar dissolve faster. Okay, soluble means the substance will dissolve. Whether it's fast or slow, eventually those two things will mix and dissolve. It was kind of cool in class. We have 3 different temperatures of water, and we had 1 drop of food coloring. You can try this at home, and you get to see how fast the food coloring mixes itself up without being stirred. Then the opposite of soluble would be insoluble. It means indissolvable, doesn't mix. So that picture there, that oil and water, that the non-polar oil will actively avoid the polar water. So this image right here, where you've got the water and the oil droplets kind of forming, those micelles forming, is just like one of your extra credit labs. So I want to do a little plug for that. So this is a picture of my homepage on Canvas. My homepage on Canvas. I know, it's so cringy. You'll notice that button. I made it red so it pops a little bit more. It says extra credit labs. They are so fast. Honestly, like some of them are 5 to 20 minutes long. They're really fast. They're easy. It's kind of fun to get to see this stuff in action because on paper it's boring. But one of them that especially applies to that, today's lesson is this one right here. Okay, so it's a mini lava lamp. And I'm going to show you a video of my boys doing it.
What happened, Trevor?
We're doing an experiment. When we put the colored stuff in, that's what happens to it. It turns into the same color, and the circles keep going down and down, and then making it fill up with the circle. And I don't know what's going to happen if it doesn't start happening
Trevor.
by now.
Trevor.
What?
Say insoluble.
It's going insoluble.
Close. Try again. Insoluble.
Insoluble.
Yep, that means oil and water don't dissolve in each other.
My poor kids. Since I don't have labs to do with y'all, I just make them do it with me. Okay, let's look at those 2 example problems. The phrase like dissolve like implies that polar substances dissolve other polar substances, the like. And non-polar substances will dissolve the non-polar substances. Okay? So, canola oil. There's the molecular formula for it, is insoluble in water. Choose the best explanation as to why. So the first thing we need to know for this question is insoluble. Means doesn't mix, doesn't dissolve. Okay? The next thing you have to know for the homework checks and for the quiz this week is that water is a polar molecule. Okay? That's something to memorize. Okay? Which means that B and C are incorrect answer choices. So those are garbage. You take out the garbage answers. Water is polar, A. That looks good. So canola oil must be ionic. We haven't really talked much about ionic this week, so let's look down at D. It says water is polar, so canola oil must be nonpolar. And that's going to be our answer. That's why oil and water don't mix. Okay, so you'll notice questions like that on your homework this week. There's definitely one like that on your quiz this week. That's how you do them. Okay. So let's look at rate of solutions next. Whoops. 3 things that affect the rate of solution. So how fast does something dissolve is what we mean by rate of solution. How long does it take different compounds to dissolve? All right, pause it if you need to. The first thing you can do to affect the rate of solution is changing the particle size, which basically just means crush it. Okay? If you have a sugar cube and you crush it up, you increase how fast it dissolves. Okay, and that's this image down here at the bottom. When you have a sugar cube, the water can't get to the inside molecules. So you have to dissolve the outside first. Whereas if you crush it, then you have a higher surface area. So solvation occurs faster. The second thing you can do to increase the rate of solution or to make something more soluble is to agitate it, which is just a nerdy way of saying stir it up. Okay? Stirring something that's trying to dissolve increases the rate of solution quite a bit. And then the last thing is increase the temperature. So higher temperature dissolves more quickly. Okay. So that means if one goes up temperature, then solids dissolve faster. That goes up as well. Okay. So here we go. Our example problems on the top of the next page. It says temperature and the solubility of solids have a blank relationship. So we're looking for inverse or direct as your choices. Okay, so let's look at this. Hot milk dissolves more cocoa. So if I have higher milk, I have higher dissolving, which is a direct relationship. They go up together and down together. Okay, direct relationship between temperature and dissolving. Circle the correct conditions below. You'll notice this a ton on your homework and quiz this week. Problems just like this. So if you need to increase the solubility means more dissolves and it dissolves faster. Then what should you do? You should increase or decrease agitation, which is nerdy for stirring, and increase or decrease temperature. If I want it to dissolve more, then I need to stir it more, increase it. And if I want it to dissolve more, then I need to increase the temperature. And the last thing, number 3. 3 things you can do to make a sugar cube dissolve faster in tea. Okay, and those are the 3 things we talked about on the last page. Crush it, stir it, and heat it up. Okay, good job. The last thing we're going to look at on today's lesson is saturation. So how much is able to dissolve. So saturation is the amount of solute that a solution can hold. So at what point with you pouring in that chocolate into your chocolate milk does it start to show up at the bottom? And there are 3 types of solutions, okay? Unsaturated, saturated, and supersaturated. And I like to think of the word saturated as being full, okay? So you have an unfull solution, you have a full solution, and you have a super full solution. So saturated solution is one that has already dissolved the maximum amount of solute. So you can't make your chocolate milk any chocolatier. And that's a wonderful science word, chocolatier. Okay? Basically what it means is all of the water in your solution is already being used solvating a different solute. So it's already surrounding, it's occupied. When you have a saturated solution and you add more salt to it or add more sugar to it, that extra just falls to the bottom because your solution is full. You can have an unfull solution, an unsaturated solution. So that's less than the maximum amount is already dissolved. So if you add more sugar to it, the sugar will disappear and dissolve. Okay, you can keep dissolving more. And then the last one is a supersaturated solution. Now, supersaturated solutions are, solutions that have been tricked or have been manipulated, scientifically to dissolve more than they should be able to. Okay? So you do this by heating it up first and then cooling it down. And then if you add extra solute to it, you get these crystals that form. And I'm going to show you a video of that. Actually, I might just do it on a document camera for y'all. So that word precipitates. Normally you think about precipitation as raining, but we're actually talking about crystallization. So the words precipitation or crystallization are a huge hint that it's a super solution, a supersaturated solution. Okay. That video has not been working, so I'm going to skip it if I can. Here we go. Okay. So our 3 types of solutions, and you don't have to write this down. But a saturated solution, it says it can't dissolve anymore. So if you add in extra to it, it just settles. And that's if you make really bad sweet tea. Okay, you can see there's like this syrupy, thick layer at the bottom because the solution above it is already full, so the extra falls out. In an unsaturated solution, more can dissolve. So if you add in more sugar to it, it disappears and dissolves. And then a supersaturated solution, again, has been heated up to dissolve extra, and then it can precipitate and crystallize. If you've ever made rock candy, that's how you do it. And that's going to be one of our DIY extra credit labs this week, if you want to check that out, making rock candy. Okay. Looking at our beakers, I can tell that this one is a saturated solution because you can see the extra salt or whatever that is at the bottom. So I know that this solution above it must be full, so the extra fell out. But looking at these two beakers, they look the exact same. So if I want to be able to tell which one is supersaturated, I can add one more piece of salt to it. Okay? Adding in one more piece of salt, if I see this happen on the right, I know this one must have been supersaturated because it's precipitating or forming a crystal. And this one on the left, it just dissolved it. So I knew that that one was unsaturated. Okay? Some more cringy jokes for y'all. Okay, let's switch to the document camera so I can show you this. Okay, so what I have first is the rock candy, okay, that we made using supersaturated solution. So I heated up the water so that it dissolved extra sugar, and then I slowly cooled it back down. So that sugar stayed dissolved until it started to precipitate and crystallize on this little piece of wood, like wood splint that I put in there. Okay. The other form of supersaturated solution I wanted to show you, most of you probably did in class with us the week before spring break, or during thermochemistry we did this as well. And what I have here, you can see it's just this little liquid pack. You can see the bubble in there, and I've got that coin. So this is a supersaturated sodium acetate solution, which means I have tricked it into dissolving more than it should be able to. So when I activate it, you can see it's crystallizing, it's precipitating, and sending out this crystal. And it's super hot as well. It's an exothermic reaction. Okay, I'll show you that again right here. And now I'm going to hold this in my hands because it's cold out today. I'm going to love that. Oop, there it goes. Okay. You can see the supersaturated solution is precipitating and growing out that crystal. And it feels so nice. All right. The last thing I want to do before I'll send you to your really quick homework check today is taking a look at these examples. Okay. And the reason I wanted to do this on the document camera with you is just so you can see how I'm using keywords. Okay. So number one, it just wants me to put S if it's a saturated, SS for super saturated, and US for unsaturated. So it says on number one, the extra solute will settle at the bottom because the maximum saturation point is already reached. Okay. So the extra solute doesn't dissolve. The extra falls to the bottom and doesn't dissolve. And that's because this solution is already full at the maximum, saturated. Number two says one more crystal added causes many more crystals to separate, making one large collection of crystals, which is that crystallization or forming a precipitate. That's this one. Making crystals is pretty super, guys. So super saturated solution. That's how you'd know. If you have just a pinch of salt added to a bottle of water, it's going to dissolve, and there's probably more that you could add to it. So we'd say that's a solution that's unfull. You can add more salt to it. More solute could be dissolved, so it's not maxed out yet, which means it would be unsaturated or unfull. Okay, those are the key identifying words you're looking for on your homework check today. All right, y'all. Thanks so much. Just so you know, lesson 2 is super fast. Okay? Thank you.